Right. So the next topic we're going to take a look at is theoretical yield and the limiting reactant or limiting reagent. The theoretical yield is the amount of compound you could theoretically make. And then the limiting reagent is the reagent that limits the theoretical yield. So let's just backtrack a little bit back to our sandwich analogy. And we'll see how that works with our water formation chemical reaction. Right. So remember in our sandwich equation, we had 2 slices of bread plus 1 slice of cheese will give us 1 sandwich. And then our question is going to say we have 12 slices of bread and 8 slices of cheese. How many sandwiches can you make? Right, so our sandwich has 2 components, the bread and the cheese, and what we want to do is calculate the theoretical yield for each of them, and then whichever one is the smaller one is the actual theoretical yield. So let's go ahead and take a look at that. First off, we're going to start with each component. So we have 12 slices of bread, and we're going to see how many sandwiches we can make. So we have 12 slices of bread, and then we're going to use our mole to mole ratios. That tells us we need 2 slices of bread for every 1 sandwich. Cancel out the B's, and we come up that we can make 6 sandwiches. And then we do the same thing for the slices of cheese. We have the 8 slices of cheese. And then for every 1 slice of cheese, you can make 1 sandwich. So we come up with 8 sandwiches. So if we think about it, how many sandwiches could we make? Could we make 6 sandwiches or could we make 8 sandwiches? Well, it's always the lower value, right? Once you make 6 sandwiches, you are going to run out of your limiting reagent, the bread, and you're not going to have enough bread to make any more sandwiches, right? So whichever one is the lower value is the limiting reagent. So we'll say that we can only make 6 sandwiches. That is our theoretical yield, the 6 sandwiches. And then we can say that B is the limiting reagent. Right, bread is the limiting reagent. We're going to run out of bread and have excess cheese at the end of it, right? And remember, it's always the smallest number. And just like we can do it with the sandwich analogy, we can do it with our water analogy. So remember, we combine 2 hydrogens or 2 H2s plus an O2 to get 2 H2Os. So if we have 2.0 moles of H2 and 1.5 moles of O2, how much water can we make? And we'll follow the same process that we did for the sandwiches. We'll take a look at each reagent individually, see which one it gives us the lower yield, and then that's our limiting reagent and our theoretical yield. So we'll start off with the 2 moles of H2. And then use our mole to mole ratios. That tells us for every 2 H2s, we get 2 waters. Cancel out the H2s, and we can see that we can form 2 moles of water from the hydrogen. And then we'll do the same thing with the oxygen, right? So we come up with 1.5 moles of O2. And then we use our mole to mole ratio for every 1 O2. You can make 2 H2O. And in this case, we can make 3 moles of water. Come on, Windows security. Just leave me alone. 3 moles of water. As we can see, 2 is less than 3, and so our theoretical yield is 2 moles of water. And then our limiting reagent is the H2, right? Once we're making this water, we're going to run out of hydrogen before we run out of oxygen. And at the end of the reaction, we're going to have theoretically 2 moles of water and then we'll have some leftover oxygen. So not too bad of a concept.